Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to be naming ionic compounds with polyatomic ions. Now, a polyatomic ion is an ion that has more than one element in it. I will cover going from the molecular formula to the name, as well as going from the name to the molecular formula. So let's get started on our examples. Okay, we have our list of examples. And also, as you can see, I have put a very short list of common polyatomic ions to the left of my screen here, just to refer back to. You will notice as you use especially the common polyatomic ions, you will naturally just memorize them unless you've had to memorize them for class. Let's start with our rules for naming ionic compounds that have polyatomic ions. Our first rule, just like with our monoatomic ions, is you name the cation first and you name it with its elemental name. However, according to rule number 2, when we name our anion, we are simply going to use the polyatomic ion's name. My first example here, I am going to name both of my ions. Let's start with the cation. Na, I know, is sodium. CO3, that is a polyatomic ion because it contains both carbon and oxygen. If I take a look at my list over on the left, I can see I have CO3 right here. Its name is carbonate. I simply use its name. For my first example, this is sodium carbonate. Let's go to my second example. My cation, Ca, I know is calcium. SO3, I'm going to take a look at my polyatomic list. I see SO3 close to the bottom. That is sulfite, so I simply use its name. For my last example, my cation is Al, that is aluminum. CrO4, I need to find on my list. Here it is up here. That is simply chromate. Notice, just like in my monoatomic naming, I do not specify how many of each ion I have. So I did not specify that I have 3 chromate ions or that I had 2 aluminum ions. I simply named the cation and then I named the polyatomic anion. Let's switch gears and go from the name to the molecular formula. Again, just like with the monoatomics, we're going to need to do a little bit of math. So if I take a look at my first example, calcium nitrite, calcium I know is simply Ca. If I look at the periodic table, I know that its charge is 2+. Nitrite I'm going to find in my list. Here is nitrite. I'm going to write it out. That is NO2. It has a charge of -1. Now for my math, just like when I did my monoatomic, calcium is a +2. I'm adding that to nitrite, which has a charge of -1. This is going to give me an overall charge of +1. Now I am looking to form a neutral compound. That means my charges must add to 0. Obviously +1 is not 0, so I need to modify this. And so what I'm going to do is I'm going to use 2 nitrites. That means my overall charge is now 0. I have a neutral compound. That means I need 2 nitrites. Now I simply cannot do this because that would mean I actually have 22 oxygen atoms there, which is not what we want to convey. I'm going to use my parentheses to say that I have 2 nitrite polyatomic ions. Now let's rewrite this a little cleaner without our charges. Calcium nitrite is simply this. Let's go on to our second example. Barium phosphate. Barium, I I know is Ba. If I look at the periodic table, I can see that barium, just like calcium, has a charge of 2+. Phosphate I'm going to find in my list. Here is phosphate down here. Phosphate is PO4 and the charge is 3-. Now to switch up to my math. Barium has my charge of 2+. I'm going to add that to phosphate, which has a -3. This gives me an overall charge of -1. I cannot do that. In order to make this a neutral compound, I'm going to use a 3 here and a 2 here. You can see mathematically that becomes 6 plus a -6, which gives me a neutral compound. Okay, this means I'm going to need 3 of my barium ions, and I am going to need 2 of my phosphate ions. But again, let's rewrite in one color without my charges. Here is barium phosphate. Last example, magnesium sulfate. Magnesium, again, easy. Magnesium, again, charge of 2+. Sulfate, I'm going to find sulfate on my list. Here it is right here. That is SO4 with a charge of 2-. Let's switch up to do my math. I have a +2 plus a -2. This already equals 0 as a neutral compound. That is fabulous. So let me rewrite without my charges. Magnesium sulfate. Our last example, magnesium sulfate, was again to show you if you're using crisscross, just be careful and be aware of when it's appropriate to use crisscross and when you should not use it. However, the math will always lead you to the right molecular formula. One of the common mistakes I see when using polyatomic ions is students will forget to put parentheses around the ion when they need to have more than one. So don't forget your parentheses. Thanks so much for watching.